Okay, so hello everyone. Welcoming you to a discussion of the ISI MSQE 2022 paper. And today we are going to start with the PEA part of the questions. So, coming to the first question over here that is given, question number one. So, over here you can see that the utility function has been given to be u of x comma y is equals to a into square root over x into y, where x and y are positive. So essentially this is a standard Cobb-Douglas utility, so we can simply write it down in this way: x to the power half, y to the power half. And what is my budget constraint that is given? Px into x plus py into y is less than equals to m. So this is the budget constraint given to us with inequality. So obviously at optimal this will hold with equality. So we'll consider the budget line like we usually do. That means the entire income has to be exhausted for the optimal choice. So px into x plus py into y has to be equals to m. And additionally we are also given the information that the price of good x is same as price of good y. So px equals to py greater than 1. And we are told to show some relationship between x star and y star. So first of all, let's find that out. So how do we do that? At optimal, we know that when a two commodity framework, marginal rate of substitution should be equals to the price ratio, which is the slope of the budget line precisely. So what is the MRS over here? It is marginal utility of x, which is del u del x divided by del u del y. So that will be a times half into x to the power minus half y to the power half divided by a into half x to the power half y to the power minus half. So this will simply become y by x. That means y by x is equals to px by py. That is the optimal that we get, optimization condition. This is it. So now what we'll do, we'll replace this in the budget line. Therefore, from the budget line, two times, if we want to find out the optimal x, we'll replace it in this fashion, which is equals to m. So what is x star? It is half divided by half into m by px. And similarly, if I want to find out the optimal y, then we'll substitute for y and we'll get this structure. 2 times py into y equals to m. So this means what is my y star? Which is equals to half into m by py. And it is given in the question that py is equals to px. So essentially what we can see from these two things, so this is the expression that we obtained for x star, and this is the expression that we obtain for y star. Therefore, x star is equals to y star. So this is the condition relationship that we get. So this is essentially option B. Now moving on to question number 2 over here. So coming to question 2. So let us just have a look at the question first. Question 2. So the question 2 says that the utility function of the consumer u of x1 comma x2 is equals to 3x1 plus 2x2. So this is essentially the perfect substitutes type. So the consumer will buy the good that is essentially cheaper. That is the idea of a perfect substitute. And we are also given that price of good 1 is P1, price of good 2 is P2, M is the income, the standard notations. And we are told to consider the following optimization problem. So let's see what they have given in the question. So the optimization problem is written as the Lagrange, which is equals to 3x1 plus 2x2 plus lambda times m minus 2x1 minus 3x2. So this is the Lagrange that is associated with the optimization problem. Now essentially that you can see over here that this part, so what is my budget line, if you can see, it is m equals to 2x1 plus 3x2, right? So essentially this 2 is what the price of good 1, and what is this 3? It is the price of good 2. Now we know that in perfect substitutes we have a possibility of corner solutions. So let us do that intuitively first, and then we can come back to the Lagrange. That will be a faster process in these kind of entrance exams. So for the budget line, so let us just find out the slope of the budget line. It is 2 times dx1 plus 3 times dx2. Therefore, what is the absolute slope? Minus dx2 by dx1 is essentially 2 upon 3. This is the slope that we are looking at. And for the indifference curves associated with it, so this will be 0 is equals to 3 times dx1 plus 2 times dx2. So this will be minus of dx2 by dx1 is equals to 3 by 2. So this is essentially the slope of the budget line, and this is essentially the slope of the indifference curve. That is the marginal rate of substitution. Now if you just plot them, you'll understand. So what do we see over here? That the indifference curves for these kind of utility function are actually straight lines. We already know that. And essentially in this case, it will be steeper than the budget line. So firstly, let me just draw a budget line arbitrarily. We need not be, sorry. So this is the budget line, and x2, x1. This is the budget line. Now how will the indifference curves look like? It will be straight lines and steeper. So now you can understand that where will the optimal take place? The farther right you move the indifference curves, so where will the optimal come? It will come at the horizontal intercept with the budget line. So this is where your equilibrium will lie. Therefore, what we can see, therefore at equilibrium, the consumer consumes no x2. x2 star is 0. And in fact, it's kind of evident also, because the price of good 2 is 3 and price of good 1 is 2. So given the perfect substitute kind, the consumer goes for the cheaper good, so he goes for x1. Therefore, what will be the optimal x1 from the budget line? P1 x1 plus P2 x2 should be equals to m. The entire income has to be exhausted in purchasing the two goods, right? So at optimal, this should hold. The optimal bundle should satisfy the budget line. Now x2 star is 0. So what will we have? P1 x1 star is equals to m. That means what is my x1 star? It is m by P1, and PA1 has been given to be 2. So that comes out to be m by 2. So x2 star is 0, x1 star is m by 2. Now along with that, we are also told to find out the optimal Lagrange multiplier. So for that, what we can do? We can simply get back to the Lagrangian, and we already know this information. We already have got this intuitively that this will be 0. So we can simply substitute it. It's not a big issue. So my simplified, so my Lagrange becomes 3x1 plus lambda times m minus 2x1. So now if I maximize this, del x1 equals to 0, then what do I get? 3 plus lambda times minus 2 is equals to 0. That means 3 minus 2 lambda is equals to 0. 3 equals to 2 lambda. So my optimal lambda star is 3 upon 2. Therefore, we are told to find the optimal x1 star, x2 star and lambda star, which we have obtained as m by 2, 0, and 3 by 2. And that exactly matches with my option. Okay, thank you.